Hello everybody. In my previous class, I discussed about the substitution reaction. Now I'll start elimination reaction. Now if I give you some example, you can understand. Suppose we are taking ethyl bromide. This one is ethyl bromide. Now whenever we are giving aqueous KOH, then we are getting ethyl alcohol or ethanol. So the type of reaction is here substitution reaction. But if I give alcoholic KOH and heat, then there will be formation of ethylene, and the type of reaction is called elimination reaction. As here HBr is eliminated from this molecule and it is forming that ethylene, CH2 double bond CH2, and this type of elimination also called beta elimination. So if we change the reaction condition, in case of aqueous KOH it is more polar, and when we are using KOH in alcohol then it is less polar. So in less polar solvent elimination reaction is favored, but in more polar in aqueous solvent the substitution reaction favored. Next we will discuss about the mechanism. Then you can understand why it is called beta elimination reaction. Suppose this one is the corresponding halide. Then here this carbon is called alpha carbon and this carbon is called beta carbon. So whenever we are using alcoholic KOH, OH minus is acting as base here and will abstract this proton and this bond will break, and this is called leaving group that will eliminate. So finally we are getting CH2 double bond CH2. So the base is abstracting proton from the beta carbon. That is why this reaction is called beta elimination reaction. Next we will discuss one rule. That rule is called Set-Jeff rule. In case of alkyl halides having two different carbons beta hydrogen, that means there will be two different carbon beta hydrogen and then more than one product is formed. And in such cases, the more substituted alkene is the major product, and this is known as Set-Jeff rule. If I give you one example, then you can easily understand. Suppose we are drawing this type of molecule. Here we have to take this bromine here, middle. Now the name of this molecule is 2-bromopentane. This is 2-bromopentane. Now here the carbon attached to halogen is called alpha carbon, and the right side carbon is called beta, and here also beta. Left side carbon is also called beta. So in this molecule there are two types of hydrogen. Now if I give OH minus aqueous KOH, then there will be formation of two type of product. One will be CH3, CH2, CH double bond CH3, and another will be CH3, CH2, CH2, CH double bond CH2. So when that OH minus abstracting this proton, then this more substituted alkene is formed, and that will be the major product. We know that more substituted alkene is very much stable because of hyperconjugation, better hyperconjugation or increased number of hyperconjugative structure. Now, if this OH minus abstract this right side proton, then there will be less substituted alkene, that will be the minor. So this will be the major product. Now what will be the percentage? This will be 81% and this is 19%. So here we can easily understand that the Set-Jebb rule, that more substituted alkene will be the major product. Now there may be some case where there is chance of cis-trans isomerism. In case of Set-Jebb elimination, if the alkene is capable of showing cis-trans isomerism, then trans alkene, being more stable, is always formed as the major product. Here also we have to take one example, then we can understand. If we take the example of CH3, CH2, CHBr, CH3. This is 2-bromobutane. So in case of 2-bromobutane, if I give alcoholic KOH and apply heat, then we will get, there are two types of beta hydrogens are there. This side one hydrogen and this side one hydrogen. So here we will get the trans product as major. So this is trans to butene, the major product. And cis will be the, this is also most substituted. This will be the minor. If I write their percentage, then you can understand that will be 71%, there will be 10%. And another, that will be the less substituted alkene, CH3, CH2, CH double bond, CH2. That will be the 19%. So from here we can easily understand the trans isomer will be the major product, as the two methyl groups are in the opposite side, so there will be less steric hindrance. But in case of cis, two methyl groups are in the same side, so the stability of this type of alkene is very less. Next, we will discuss the mechanism of elimination reaction. Generally, there are two types of mechanism. One is called E1 mechanism, another is called E2 mechanism. So, what is E1 mechanism? E1 mechanism is unimolecular elimination reaction. Unimolecular elimination. We can take one example. The case of tertiary bromide. So this type of mechanism is generally followed by tertiary alkyl halide, because after this there will be formation of carbocation like SN1. and this step is also slowest step or called RDA step. This is the step 1. Now in step 2, the base will abstract this proton. This proton will be abstracted by base, and this reaction is fast, and finally we will get the alkene. So if we write the rate of this reaction, that will only depend on the alkyl halide. As rate depends only one molecule, so the type of the reaction will be the unimolecular reaction, and this will be known as, or this is called as, unimolecular elimination reaction. Next we will discuss E2 or bimolecular elimination reaction. E2 is bimolecular elimination reaction. Generally, primary alkyl halide follow this type of mechanism. And here, if we take the example of ethyl bromide, then we can easily understand. This is also a single step mechanism. So here OH minus will abstract this proton, and that bromine will, this carbon bromine bond will break and bromine will leave as Br minus. From here we will get that alkene. This is the RDA step. Plus Br minus plus H2. So here if we write the rate equation, rate will be depend on both on the concentration of alkyl halide and the concentration of OH minus. So as here in the rate equation there is two molecule, so it is called bimolecular elimination reaction. Now from this two type of mechanism we can easily understand generally this type of E2 elimination will occur in case of primary halide, but E1, as there is stability of carbocation, for in the case or in the case of tertiary alkyl halide, so E1 type of mechanism will observe in tertiary alkyl halide. Next we will discuss the reactivity of alkyl halide for elimination reaction. Generally for elimination reaction, the tertiary halide reactivity will be higher compared to the secondary halide, then there will be the reactivity of primary halide. So primary halide elimination chance is very less. Now we have studied two type of reaction, one is substitution and another is elimination. So there may be some confusion. When there will be substitution or when there will be elimination, or both of type of reaction will take place in the same time. Now so next I will discuss elimination versus substitution. Elimination has normally high activation energy. You know what is activation energy? That the energy barrier between the reactant and product. So as in case of elimination reaction, as the higher temperature is required, so higher temperature favor the elimination reaction, over the substitution reaction. Next, solvent. Solvent plays a great role. Solvents with low polarity like alcoholic KOH bring about the elimination reaction, but solvent with high polarity, as for example aqueous KOH, favors the substitution reaction. Next, we will discuss about the structure of the halides. So, if the structure is tertiary alkyl halide, it will favor elimination reaction. If the alkyl halide is primary, it will favor the substitution reaction. That also depends on the type of the solvent also. Generally, if we use a strong base, that favors elimination reaction. But if we use a strong nucleophile, that will favor the substitution reaction. In case of sterically hindered base, elimination is favored. But if we use unhindered base, then it will act as a nucleophile and favors the substitution reaction. Here we can think about one example. Suppose we are taking one hindered base like tertiary butoxide. So here if we take one molecule like this, this is 2-bromopropane. So now what will happen here? Whether elimination reaction or substitution reaction. As the size of the base is big, that means sterically hindered, tertiary butyl group is there. So it cannot act as a nucleophile. Better it will act as a base and it will abstract the hydrogen and there will be elimination reaction. So in this case it will abstract the proton and there will be formation of alkene. So this is elimination reaction. Elimination. But if we take less hindered or unhindered base like CH3O minus methoxide ion, then if we take the same substrate, then there will be substitution reaction. This will attack here and we will get a product like this. That is one ether type compound. So this is substitution reaction. So hope you can understand the comparison between substitution and elimination reaction. Next I will discuss the last type of reaction, that is the reaction with metals. First we will discuss the Grignard reaction or Grignard reagent. If alkyl halide reacts with metal, suppose we are taking C2H5Br and we are reacting with magnesium, taking the solvent dry ether, then there will be formation of C2H5MgBr. So here metal atom is attached with carbon atom and we know that the metal valency here magnesium +2 and bromine will be -1 and here also carbon -1. So this type of reagent is called Grignard reagent and the reaction is called Grignard reaction. And these reactions have these type of reactions have huge type of application or wide application. We can prepare different types of compounds. Here if we give water, then there will be formation of C2H6 ethane. Here if we give alcohol, so this can easily take one acidic proton. There also formation of ethane, and here it will convert into magnesium hydroxybromide. Here in this reaction if we give alcohol, then it will form MgOR. So in this way we can prepare different types of, it is a delta negative or negative charge on carbon atom, and here also negative charge, here two positive charge. So as metal is present in organic compound, so this is also one type of organometallic compound, and the type of reaction is called Grignard reaction. Next we will discuss Wurtz reaction or Wurtz reaction. WURTZ. This method actually is not suitable for the preparation of unsymmetrical alkanes. If we take methyl iodide and sodium, and we have to use dry ether here also, then there will be radical type of mechanism and we will get ethane molecule with formation of twice Na. Generally methyl iodide or bromide type of alkyl halides will give the better yield, and in this reaction we can only prepare the alkane having even number. If we take, or if you want to prepare the uneven number alkane, then there will be problem. If we take methyl iodide plus ethyl iodide, if we want to prepare propane, then definitely there will be formation of propane, and along with this propane there will be formation of ethane, there will be formation of butane also. So we will get a mixture of alkenes, and the separation is very much difficult. So how to solve this type of problem? This type of problem is solved by our Nobel laureate E.J. Corey, and the name of the reaction is Corey-House synthesis reaction. Corey-House synthesis reaction. Here we have to take the alkyl halide. Here we are taking that alkyl halide containing 2 carbon atom, and in the reagent, Corey-House reagent, that is we are taking that Me2CuLi, or you can tell or write CH3 whole twice CuLi, dimethyl copper lithium in presence of dry ether. Definitely there formation of propane CH3 CH2C as the only product, and formation of methyl chloride plus copper lithium. There will be formation of lithium chloride and methyl copper. So in this way we can prepare alkane having odd number. Otherwise, if we try in Wurtz reaction, we will get a mixture of compound. So these are the reaction of alkyl halides with metals. Hope all of you can understand, and today up to this. Next day I will discuss the preparation or formation of haloalkanes and their chemical reactions. Thank you.